Due to the shortage of ventilators currently in the world, hospitals are forced to manually respirate people, taking valuable hands of healthcare workers away from other tasks. We saw an opportunity to help the community using the skills we have. Almost all hospitals have a supply of manual respirating bags, much like this one, and with increased need for ventilators and supply of these manual bags in mind, we set out to create a device that could squeeze the bag in place of a medical professional and allow them to attend to multiple patients at once. We set out to create a cost-effective yet fully functional ventilator. Our ventilator is designed to be highly compact and portable. Due to its small size and modularity, we have the ability to manufacture many units quickly at a low cost. High-end ventilators currently cost over $20,000 per unit. Our unit's material cost is about $150 in raw materials and can be manufactured for only $500 with a quick production time.
The ventilator is controlled by only 3 dials and a switch, which allows for simple user interface that can be learned quickly and gives control over every function of ventilation. The use of individual dials allows for quick and direct changes to be made to each parameter of a breath. The controls are wired to an Arduino, which, depending on the mode, takes the input and modifies the steps and speed of our high-precision stepper motor. Our system also has a number of safety features, such as a battery backup, power loss alarm, and pressure alarms. Our ventilator, much like a high-end ventilator, has 2 modes, mandatory breathing and responsive breathing. In mandatory, the user can set the volume, rate, and IE ratio of necessary breaths. In responsive mode, the device can detect when the patient attempts to breathe using a pressure sensor, which then begins the compression of the ambu bag to deliver air to the lungs.
We designed our ventilator to have modular side plates that can be easily cut and assembled with minimal hardware to reduce manufacturing time and assembly time. We designed the electronics to be detachable from the unit, allowing us to sterilize them in an autoclave in a hospital setting. We designed these ribs to be modular, allowing us to accommodate different sizes of ambu bags while maintaining the most amount of air possible. The pushing mechanism was optimized to be easily manufacturable and push as much air as we can with the unit. We designed a quick latch mechanism for the ambu bag to allow the bag to be separated from the unit in case of mechanical failure or bag failure. We ran the unit through multiple hours of testing to ensure its multi-day use and reliability. Our goal with this project is to get approval from the FDA so that we can begin the manufacturing of these units and distributing them to the hospitals to fill the need for extra ventilators. The units that we have created can provide quick relief to the pandemic response, unlike any other unit out there. What we've created is far cheaper than anything else and has capabilities beyond any other current solution.